Hello and welcome to today's lecture, which is brought to you by the Frankie Program in Science and Humanities here at Yale University and by the Yale University Poynter Fellowship in Journalism. The mission of the Frankie Program is to support lectures, events, performances, and activities that bring diverse audiences together to explore the interface between science, humanities, and our culture. I'm excited about today's event, which I'm sure will do exactly that. As always, I want to thank Gary Tomlinson and the Whitney Humanities Center for their support and providing this marvelous home for the Frankie Program. And I also want to thank Rich and Barbara Frankie for their generous support for the program and for their ongoing vision of a Yale community that is more convivial, intellectually exciting, and adventurous. We all benefit from it. Today, it's my pleasure to introduce our speaker, Richard Preston. Preston did his undergraduate work at Pomona in English and got his PhD in English from Princeton University, where he studied 19th century American nonfiction writing. He's the author of 9 books on a variety of topics, including infectious disease, as we know, Redwoods, a novel, and a children's story. And of course, he's the author of many nonfiction pieces for the New Yorker magazine, including a piece just last week entitled Inside the Ebola Wars. In 1995, Preston published The Hot Zone about the Ebola virus and an accidental outbreak of the virus in a colony of research monkeys in Reston, Virginia in the 1980s. The Hot Zone sold millions of copies and terrified millions of readers. For example, novelist Stephen King wrote, "The first chapter of The Hot Zone is one of the most horrifying things I've ever read. And then it gets worse." I'm also sure that The Hot Zone inspired many of its readers to consider and pursue careers in epidemiology, virology, and public health. That fascination it fuels curiosity and a lot of what we know today. The most recent massive outbreak of Ebola, occurring for the first time in West Africa, has once again propelled The Hot Zone back onto the national bestseller list 20 years after its publication. Now, as an evolutionary biologist, I have always had a particular fascination for the insidious ingenuity of infectious disease and for the dynamics of epidemic infection. And so it's a pleasure to bring this element to the Frankie Program and to discuss it today. And so I'm happy that we have the opportunity and the foresight to bring Richard Preston here to talk to us today in this very timely lecture. His talk is entitled Ebola Breakout from the Hot Zone, and please join me in welcoming Richard Preston.
Thank you, Rick. It's really a real pleasure and a delight to be here, even in the context of Ebola. I want to start by telling you a story about Ebola, because Ebola is not just a virus, it's also a human problem. But I also wanted to let you know that I'm going to try to keep my remarks brief enough so that we have a little bit of time for Q&A afterwards. As Rick pointed out, my expertise is in English literature. And there are surely people in this room who know more about Ebola virus epidemiology and molecular biology than I do. And it would be really fun to invite the Yale community as a whole to get into a discussion about some of the things that I'm going to be presenting and talk a bit about Ebola. And I will try to answer whatever questions you may have. And there may be people in the room who can answer them better than I can. Now, the Ebola virus has probably been breaking into the human species since time immemorial in small outbreaks in equatorial Africa. The virus was never able to establish a firm foothold in the human species as a new host. It lives somewhere in equatorial Africa in some unknown creature, possibly a bat, or it may well live in some parasite of the bat, such as a wingless fly, a tick, or a mite that lives on the body of the bat and is the actual carrier of Ebola. We simply don't know. That isn't known. In 1976, in a small upcountry rural hospital in Yambuku in what was then Zaire, now the Democratic Republic of Congo. Ebola surfaced and came to the notice of doctors for the first time. They didn't know at the time what it was. All they knew was that it was an exceedingly lethal infectious disease, presumably a virus, and it got into the staff of the Yambuku hospital. One of the victims was Sister Beata, a Belgian nun, who worked there, and here we see her just prior to 1976 in a log canoe on the Ebola River waving goodbye. This is the last known photograph of Sister Beata. The virus got into the medical staff of the Yambuku hospital. We don't know who patient 0 was. We don't know where it came from, but it raced through the staff and it killed a number of people. We see here, the gentleman with the beard and the glasses is Father Lutens, a priest. And when Sister Beata lay dying, he gave her the last rites. She was weeping at the time. And one of the things that happens with some cases of Ebola is you can get tiny pinpoint hemorrhages on the rims of the eyelids. Apparently she had blood on her eyelids, and the blood leached into the tears running down her face. Father Lutens began weeping while he was giving her the last rites. He took out his handkerchief and he wiped the tears from her face, and then he wiped the tears from his own face. And he was dead 14 days later. At first, international health authorities had absolutely no idea what was going on in Yambuku, but it was extremely alarming. And virus experts from around the world began getting teams together and going in. And one of the very first people, in fact, the first medical doctor from the outside world to reach Yambuku was a Belgian physician by the name of Francois Rupaul. He was a young doctor. He had never been posted to the field before, and this was his first major outbreak. He had a good deal of difficulty reaching Yambuku. When he finally got there, he arrived at night, and he went into the building. He found that essentially most of the medical staff was dead, and the patients that had been there had left, had been too frightened. He walked into the obstetrical ward and the operating room. Ebola virus is particularly devastating for pregnant women. It will induce a spontaneous abortion or miscarriage, accompanied by profuse hemorrhage, in which the infant dies and the mother typically dies as well. So when Dr. Rupaul went into the obstetric ward, he found pools of blood all over the floor and used surgical sponges saturated with blood all over the place. And the OR was even worse. And we're talking about a very, very rudimentary hospital equipped with very little of what we know of as effective modern tools and techniques. So he realized very quickly that these areas were presumably laden with some unknown virus. Ebola at that time did not have a name. Nobody knew anything about its characteristics as an organism. It was assumed to be a virus, not bacterial. Nobody had any idea how it was transmitted from person to person, but it was obvious that it caused hemorrhaging in some patients and had an extremely high case fatality rate. The reported case fatality rate in that early outbreak in Yambuku is something around 90%. 9 out of 10 were said to die. One wonders really if that figure is at all accurate. It's just hard to say. I don't think there was any really careful epidemiology done. In any event, Jean-Francois Rupaul went to bed in a small bungalow next to the hospital that night. And he reported later that my first night was calm. It was a night of quiet and silence because people were dead or they had fled. But then at 5 o'clock in the morning, a woman was brought in, and she was in childbirth, and she was in terrible distress. She was shaking with fever. She had a very high fever, and she was hemorrhaging profusely from her birth canal. Rupaul was the only doctor on the scene who was able to make decisions or do anything. The obstetrical ward was clearly not the place for this woman. So they set up a table on the porch in front. And he had a couple of flashlights, and he turned those on for illumination. And then the woman was lying on the table with nurses around. There were several nurses who had stayed, despite the obvious danger to themselves. By this point, the remaining staff understood that their lives were in jeopardy by simply being near patients. And Dr. Rupaul then examined the woman, and he came to some determinations as a doctor. The first was that the woman was in grave distress, that she was at the end of her rope and was likely to die if nothing was done, that the baby was in breach, was presenting the wrong way, the woman was hemorrhaging, and in order to save the life of the mother and the baby, he would have to perform a procedure. However, a cesarean section was completely out of the question. She couldn't be brought into the obstetrical ward or the OR. And in any event, he had no anesthetic. There were no anesthetics available. There were only, the light was just the light of the flashlights. And he had rubber gloves, and he had a cloth gown. So he made a decision as a doctor to perform a very old 19th century medical procedure known as the Zarate Procedure. And it's an alternative way of delivering a baby. He took a scalpel and he separated the bones of the pubic symphysis. Now in the pelvis, if you feel your pelvis, right down in front, at the front of the pelvic bone, the bones join together right here, somewhat below your navel. It's a hard area. But if you press hard, you can actually feel that the two front bones of the pelvis are joined by a layer of very tough cartilage. It's a joint there. And while the woman did not have anesthetic, he then split her pelvis through the cartilage like that. And then he had nurses open the woman's legs, and her whole pelvis came open like this. And then he brought the baby out. The baby was covered with blood. There was blood everywhere. And the woman was obviously in distress. And then that was when Dr. Rupaul discovered that the baby was in breathing arrest. And without thinking what he was doing, he tore off his surgical mask, and he placed the baby's face up to his face, and he rescued the baby's life. He breathed air into the baby's lungs, and he saved the baby. And then he pulled back, and he suddenly realized what he had done. His face, his eyes, his mouth, his nose were covered with the baby's and the mother's blood. His hands were covered with blood, and the nurses were standing there in shock. And one of them said to him in a quiet voice, "Doctor, do you realize what you have done?" And he said, "I do now." Now, I'm telling this story because this is what doctors in West Africa have been facing today. And it's a situation where if you are a trained physician, you move in and you do what you have to do, you do what you've been trained to do, and you don't think about your own personal safety. Dr. Rupaul later reported, "This was the only time in my medical career that I was not just afraid, but felt and lived real terror." He survived. As it turned out, the woman's fever was from malaria. She didn't have Ebola. And he had saved the life of the child and the mother, who went on to live completely normal human existences in Zaire. Now, since then, Ebola virus has made another 23 appearances on the planet, 20 of which were outbreaks in which it was transmitted from one person to another. And the total cumulative number of deaths there has been about less than 2,000. The outbreaks tended to be small, and they tended to burn out quickly. And doctors, after a while, got a sense of what I think was complacency. And there was a general consensus in the medical community that Ebola virus was not much of a threat and could be easily controlled. But nature has a way of surprising scientific people if you're a scientist and you make an assumption that isn't really based on sufficient data, nature has a way of completely surprising you. Now, this recent outbreak began, it seems, on about December 6th, 2013, when a 2-year-old boy in a small village called Meliandou in Guinea died of what we now know was Ebola virus. It was a type of Ebola that appears to be a little bit different than all the other Ebolas that have appeared. Later on, I'm going to talk a little bit about the genetics of viruses and of Ebola. This particular Ebola began to move, and it left the village, and it moved jumping from person to person to person, setting up what are known as chains of infection. Now, when a virus is making a so-called trans-species jump into the human species from some host species, when a virus is attempting, so to speak, to turn the human species into a new host, if you can talk about the goal of the virus, this is a little bit tricky because the organism does not have anything like a consciousness as we would describe it, and it has nothing like intention as we would talk of intention. But what it does have is biological sophistication, and it is set up genetically to be opportunistic. The goal of the virus is to set up endless chains of infection in its new host, chains that are unbroken and never end. And in that sense, the virus which is making the trans-species jump, which HIV did, is making itself immortal in its new human species, its new host. Something like 7,000 years ago, the smallpox virus did this. Smallpox is thought to have once lived in some natural host, probably a rodent, and probably a rodent that lived on grain. And about 7,000 years ago was the first time in the history of our species that we were gathered in large numbers congregated in river valleys in the Middle East and in China, where you had agglomerations of up to 200,000 people within a 14-day travel time of one another. The incubation period for smallpox virus is up to 14 days. And epidemiologists who have done the math and done the computer simulations have concluded that smallpox might have been making these little jumps into the human species, but it was only with the growth of agricultural concentrated populations in river valleys, and then with grain silos, with rodent explosions of rodent population living on the grain, that the virus was able to become immortal in the human species. And smallpox maintained its immortality until it was declared eradicated by the World Health Organization in 1979. And it now lives only in laboratories in a frozen state. So Ebola virus is somewhere in an earlier phase of an attempt, so to speak, to make itself immortal in the human species. We have some images. This is from Zaire in 1976, and the images are pretty much like what we're seeing today. The guy that discovered it, Carl Johnson, is still active in Ebola research. But the question is, what is Ebola anyway? This is an image of one of the virions or particles of Ebola. The virus particle looks like a strand of spaghetti, and it's composed of only 7 structural proteins that are knitted together into this worm-like, spaghetti-like shape. There are an additional 3 proteins that are enzymes that operate in various stages of the replication process of the virion, the particle. And right at the center of the particle, inside a kind of a container made of coiled protein, is a strand of RNA, which contains the genetic code of the virus. Ebola virus, one recent sample of it, they counted 18,979 letters of RNA, which is a very small genome by the standards of life. The human genome is something like 3 billion letters of DNA. And there are orchids that have, I believe, up to 10 to 12 billion letters of DNA in their genomes. It would seem that there are some orchids that are perhaps much more complicated than human beings. Ebola virus is considered to be a biosafety level 4 agent for which there is no vaccine and no cure. So if you're in a laboratory, you need to be wearing a very high degree of bioprotective gear in order to be working with concentrated, amplified quantities of the virus. These are some photographs of, this is a beautiful photograph. These are elephants in Khartoum Cave, which is thought to be one of the hiding places of the Marburg virus, which is a cousin of Ebola. When a particle of Ebola gets inside a cell, it begins to replicate like mad inside the cell. And the replication cycle peaks about 18 hours after the first particle enters the cell. And essentially, the virus turns that cell into a factory for making a lot more Ebola virus particles. And the cell rounds up. It gets a swollen, plumped-up shape. You can see a cell here that is infected with Ebola. And then the virions, the particles, begin growing out of the cell like hair. You can see them doing this. And one cell will produce thousands and thousands of these particles. Now, one of the odd things about Ebola is that the virus takes its sweet time killing the cell that it's coming out of. These cells tend to last a lot longer than human cells that are infected with HIV, which die very quickly once HIV is active in the cell. So that Ebola has this capability of really keeping that host cell alive longer and making more of itself out of that cell. In West Africa, well, the net effect on a human is that as the virus multiplies in the body, as more and more cells become infected and spew out thousands and thousands of Ebola particles, the titers of the virus in the bloodstream, that is the density or the quantity of particles in a droplet of blood, goes up astronomically. And at the end of an Ebola infection, what happens is that the bloodstream is really loaded with these particles. Nobody really understands how a person dies of Ebola virus. But clinically, we know that the blood vessels begin to leak, and capillary beds all through the body lose their integrity. The blood vessel walls just lose their integrity, and blood plasma begin just seeping out of the blood vessels. This also, for some reason, triggers clotting. And the clotting will continue. You get something called disseminated intravascular coagulation, or DIC, in which the blood essentially throws tiny clots everywhere in the body. And then eventually the clotting factors are used up, and the patient then can begin to have hemorrhages and will have multiple organ failure and go into shock. And when someone has died of Ebola, it's really hard to point to any particular cause of death, because the person has had multiple organs shut down and they're in shock, massive loss of blood pressure, and so forth. At the end of the replication phase in a human being, think of a droplet of blood large enough to make a little spot that covers perhaps a fifth of your pinky fingernail. And in that droplet of blood, there could easily be between 100 million and 1 billion particles of Ebola virus. Ebola is exquisitely infectious in direct contact with blood. And laboratory experiments suggest that as few as a single particle of Ebola virus, if introduced into the human bloodstream, can cause a fatal infection. Now, Ebola, as the Ebola outbreak widened, hospitals in West Africa quickly became overwhelmed with Ebola patients. And one of them was the Kenema Government Hospital in Sierra Leone. For many years, the Kenema Government Hospital had a laboratory for investigating Lassa virus, which is another African hemorrhagic fever virus that is devastating and is considered to be a biosafety level 4 agent because there is no vaccine for Lassa and no reliable cure for it. And a number of American researchers, including this woman here, Pardis Sabeti, who is an associate professor at Harvard University and affiliated with the Broad Institute of Genomics at Harvard and MIT in Cambridge, have been working there for years doing research on Ebola. On Lassa. Here we have the Broad Institute, where they do genetic sequencing, genomic sequencing of all kinds of organisms. Pardis Sabeti and a colleague of hers named Stephen Geyer are among the subjects of my recent New Yorker article about the Ebola outbreak. Sabeti is quite a remarkable scientist. Among other things, she is a singer and a songwriter for an indie band, 1,000 Days, and they had to put their 4th album on hold due to Pardis's involvement in the Ebola outbreak. And she began working with physicians at the Kenema Hospital, including Sheikh Humar Khan, who was running the Lassa research unit and was essentially the chief physician at the Kenema Hospital. And early on, the people at MIT and Harvard and Dr. Khan decided that it would be a really good idea to get genome sequencing of this new Ebola. And the idea was to find out how the virus is mutating. Ebola is certainly mutating as it passes from one person to the next. Because the genetic code of Ebola is in RNA, RNA viruses are known to make errors when they copy themselves, errors of copying. And it's a lot like monks who copied medieval manuscripts by hand. As they copied and copied and copied, they introduced small changes in words and letters. And as time goes by, the text changes. And as Ebola moves from one person to the next in these chains of infection, in these generations of infection, it's being subjected to ferocious natural selection, in which each person who is infected with Ebola may have multiple genomes of Ebola in their body by the time the infection peaks out. In other words, the virus may mutate inside the body of a single individual. And the question is, if Ebola is mutating, and we know it is mutating, exactly how is it changing? How is it changing in response to the conditions it's experiencing in the human body? And what could happen to it? And there's a general concern that the longer this outbreak goes on, and the longer the Ebola virus is exposed to the human body and is replicating and replicating in vast numbers, and then going from one person to the next, that you set up statistically a chance of a mutation that could make the virus far more contagious in humans, more easily to spread from one person to the next. So Sabeti in this lab and Dr. Khan began working on trying to get blood samples of patients with Ebola, and then getting the samples over here to the United States, to the Broad Institute, where they could be sequenced and read. One of the key players here was the lady on the left here, Nurse Ambala Fani. She was the head nurse at the Kenema Hospital. She was a small person and a complete dynamo who always wore a starched white uniform, except when she was in biohazard gear, dealing with Lassa patients and then Ebola patients. In any case, in May 23rd of this year, a woman arrived in Kenema, and she was having a miscarriage and hemorrhaging. And Dr. Khan suspected that, in fact, she might have Ebola. They tested her blood, and they found out that indeed she was positive for Ebola. And then Dr. Khan and his colleagues and nurse Fani, along with others at the Kenema Hospital, ended up collecting blood. They collected blood from discarded blood tubes that were going to be incinerated in a biohazard incinerator at the hospital. The reason for doing this is that it's considered to be highly unethical to take samples from a patient in a clinical setting for research. That's an anathema to clinicians and to researchers. So essentially what they had to do was they had to gather the RNA, the code of Ebola virus, from medical waste. They brought these samples over to the Broad Institute. And I don't know how many of you are familiar with genome sequencing and how it works. I knew nothing about it before I went there and interviewed people. But Stephen Geyer, who is the genome guy there, Stephen Geyer is an interesting fellow. He's apparently a very talented chef, and he was offered a chance to compete on the Bravo show Top Chef, and he turned it down and instead went to Africa to do research on monkeypox virus, which is a cousin of smallpox. But I think the reason why he's a good chef is also the reason why he's a good molecular biologist. These people they tend to be extremely precise with their hands, and they tend to have a sense of calmness and control when they're dealing with small quantities of liquid and complex recipes, which is what molecular biology is essentially all about. So Geyer and his colleagues initially they took 14 samples of human blood that were infected with Ebola virus from patients. They had a technique whereby they could take this actually it was blood plasma, but it was blood plasma that had a lot of destroyed red blood cells in it, because if you take a blood sample from an Ebola patient, it's going to look different. It's going to look like a mess. It's going to look like blood that is very sick, in fact, dead kind of blood with dead blood cells in it. Anyway, they took this medical waste, this horrible-looking blood, they purify it, and they do things like they add simply ethyl alcohol, essentially purified vodka, to this, and they can extract the RNA. The RNA comes out in solution, and they end up with a droplet called a library. And the library contained, in this case, trillions of fragments of RNA. The fragments were about 300 letters long. They were shattered RNA from many, many genomes of Ebola. And each individual fragment was tagged with a barcode of DNA, of 8 letters of DNA that linked that fragment to one of 14 patients, individual human beings who had been infected with Ebola virus. And this liquid droplet was about the size of a raindrop, no bigger than that, and it was in a little tiny microtiter tube. And then Stephen Geyer took it over to the sequencing platform, the machines at the Broad Institute, these genomic sequencing machines that each one costs $1 million, and they're about the size of a chest freezer, and there are 54 of them in the sequencing core at the Broad Institute. And the staff in this place, they take that little droplet, which is called a library. Let's think about the amount of information in that droplet of genetic code. The way Geyer described this to me, that each of these pieces of RNA with a barcode on it could be thought of as a book with a cover on it that had an ISBN number on it. And however, and this would represent an ungodly number of piles of the Library of Congress. This was many, many libraries of Congress in some gigantic pile of books, but the books are unorganized. They've never been read. Nobody knows what's between the covers, and they're in a huge pile. They're not lined up on the shelves in proper order. And so in the sequencing core, a technician took about 1/10 of that raindrop, an amount of liquid, something like a drop of moisture that hits your face when you're walking through fog, and put that on a glass slide called a flow cell. And then the flow cell is put into the business end of one of these sequencing machines. And then lasers shine on the flow cell while compounds, liquid compounds, are washed over the flow cell. And in a period of about 24 hours, they get the sequence of more than 1 billion of these little pieces of RNA. And now they have a huge amount of data. It's all in a computer. And it's then put into these giant supercomputing farms where all these little pieces of RNA are assembled because they're all overlapping. They all have little bits of code that fit together like a jigsaw puzzle. 24 hours after that, they had 12 completed, finished genome sequences of Ebola virus, 12 varieties of the virus. And it had mutated in each of the cases. They could tell, because of the way the mutations were running, they could tell who had given the virus to whom. They were able to reconstruct a chain of infection of these 14 individuals in Sierra Leone. And they were also able to show that the virus had originated with one human being, presumably the little boy in Meliandou, who could well have been infected with but one particle of Ebola virus. This entire outbreak could, at least in theory, have started with one particle of Ebola, or if not one, maybe just a few. They also found out that that in about half the cases of Ebola moving from one human being to the next, there was a significant mutation in the code, causing a slight but measurable change in a protein in the virus. And this has a direct effect on our ability to fight Ebola, because all of the drugs and vaccines and tests that we have for Ebola are all keyed into the genetic code of the virus. And if the genetic code of the virus is changing, then it can become less visible to the tests. The tests won't elicit the virus as successfully. The vaccine might not work as effectively, the vaccines that are now in development. And the drugs are also keyed to the very genetic code of this organism. Meanwhile, while this was going on, Pardis Sabeti was terrified for Humar Khan. Khan, above all, was a doctor. He was a completely committed doctor to his patients. And he stopped sleeping. He began working in the Ebola wards at Kenema. The wards became distressing and horrible to work in. As they filled up with people, some of the staff, understandably, got too frightened to come to work, until finally Dr. Khan was working alone in wearing protective garb called PPE, which is a kind of a portable spacesuit, along with Nurse Ambala, Fani, and a few other people. And Joseph Fair, an American epidemiologist, went to Kenema to see how Dr. Khan was doing. And he was shocked and dismayed to see what was happening. There was one Ebola. There were 3 wards at Kenema that were completely stuffed with Ebola patients. And the largest was a big plastic tent that had been erected by a relief agency. And inside the tent there were about 30 beds of a certain type common in Africa known as a cholera bed. A cholera bed has a plastic mattress and a hole in the center of the mattress. And the patient lies on the mattress and defecates through the hole into a bucket, because people who have cholera have uncontrollable watery diarrhea. With Ebola, they can also have uncontrollable diarrhea, which is often enough has a lot of blood in it. And when Joseph Fair looked in the window, he saw Humar Khan in there with one nurse, and the place was a nightmare. Everything that can come out of a human body was all over the floor and all over the protective garb of Dr. Khan. And as I said, in direct contact, Ebola may be lethally infectious with one single particle. Many of the people who became infected with Ebola in this outbreak couldn't remember making any mistakes at all. They thought their gear was good, they thought the decontamination process was precise, but they got Ebola anyway. In any event, one day, Humar Khan didn't come to work, and they found out that he was keeping himself at home. He had isolated himself. He was feeling ill. They had noticed that for a few days previously, Dr. Khan had been taking himself off alone, uncharacteristically, and sitting in a plastic chair and smoking a cigarette and looking off into space. He never smoked in the wards, but he was now. And later they thought that he knew he was coming down with Ebola, and he wanted to protect the staff by keeping himself away from them. When they sent somebody to his house, they took a blood sample, and he was positive for Ebola. At that point, Dr. Khan decided that he needed to get himself away from Kenema because his presence as a patient in the Ebola ward would be too demoralizing for the remaining staff. And so he climbed into an ambulance, which took him for 4 or 5 hours over these terrible rutted dirt roads to another clinic in a place called Kailahun, where he became sicker and sicker in isolation in the Ebola ward. Now, in Kailahun, there was a freezer, and in the freezer there was one human course of an experimental drug that had never been tested in humans called ZMAP. And the Sierra Leonean government regarded Humar Khan's illness as a national crisis, and they called in international experts asking for help. And the experts became aware of the fact that the ZMAP drug was there in a freezer 25 feet away from Dr. Khan. And they debated for 3 days whether to give him the drug or not. And the considerations were very, very difficult to work their way through. This was an experimental drug. He was an African doctor. He was a national hero. If he was given the drug and he died, then he would be an African doctor who had been killed by an experimental drug administered by, doctors from the developed world. The drug might have no effect on him, but if he died, it would be blamed on the drug. On the other hand, the drug might save his life. And then it would be, well, if he got the drug, why can't anybody else have the drug? And they went back and forth and back and forth. And meanwhile, Dr. Khan didn't seem to be that sick. He seemed to be hanging in there. And so there was hope that he would at least, that he had a good chance of just coming through naturally. Now, the thing about Ebola is that patients can often look like they're doing all right, but then you can suddenly go into what some Ebola experts call the crash, where you all of a sudden go into a startling decline. And it can happen in a matter of hours, where you just lose blood pressure, you have multiple organ failure, and you just die very fast. And in the end, that is what happened to Dr. Khan. The ZMAP drug eventually ended up with the two people working for a Christian medical organization called Samaritan's Purse, Dr. Kent Brantley and Nancy Rupaul, an aide. Both survived. They split the dose of ZMAP, and Dr. Brantley, in particular, seemed to, his symptoms were, he seemed to be at the point of death when the drug was administered to him. And he turned around in a period of about 3 or 4 hours on the night of July 31st this year. And when I was researching the article, I discovered that at the very moment that Kent Brantley was apparently being saved by the ZMAP drug was the moment that the burial detail finished digging the grave and burying Dr. Humar Khan in Kenema, Sierra Leone. Now, I'm thinking of the words of William T. Close, Dr. William T. Close, who died a couple of years ago, was the father of the actress Glenn Close. He was an expert in Ebola virus. He was the head of the Mama Yemo Hospital in Kinshasa, Congo, in 1976, and he was involved firsthand in that first outbreak of Ebola virus. And he said to me once, if there are lessons to be learned here, they are human lessons. This is about people doing their duty. It's about doctors doing what has to be done right now without a whole lot of heroics. Have you ever been petrified with fear, where you have no hope of control over your fate? If you're a medical worker, when the die is cast and you face Ebola, the fear goes away and you do what you have to do. You get to work. This is what Dr. Humar Khan did. I'm sure that in times to come, there will be bronze statues to him and to Nurse Ambala Fani and the others who died at Kenema. But I think what we have here is we have medical people who sacrifice their lives for their patients, and who not only that, also sacrifice their lives for science itself. And when the Sebeti and Geyer paper was finally published in Science magazine, 5 of the authors were deceased. They were all people who had died in the Ebola outbreak in Kenema. And one of the authors was Dr. Khan. Another author was Nurse Mbalu Fani. I'm going to leave it there. I have more, but I see we're running a little short on time. And I thought it would be wonderful to just open up the room to questions. And during the course of that, I might be able to tell you a little bit more about the results as we now see them in terms of the mutation rate of Ebola and what Ebola is doing right now in West Africa. Thank you very much.
Pardon, please, questions. Please use a microphone for your questions.
Any thoughts? Any questions? Yeah? Yes.
There was an interesting spread in the Sunday New York Times about photographs of workers in Africa, including an American, Stephen Hatch from Massachusetts. My question is, I gather 1 or 2 people have survived in America, and knowing American medicine as I do, they had all the bells and whistles, they got a lot of transfusions. However, one of the people in the photographs in the New York Times, a young African man, a survivor of Ebola. Do some people just, because of their unique, whatever they've got genetically, do some people just make it through the type of Ebola they have, or are the bells and whistles absolutely necessary?
This is a really good question, and I don't think at this point we really know the answer fully. We don't actually know why some people survive an Ebola infection and some do not. And it seems pretty evident that there is a genetic component, that some people just have a lucky,
Right,
a
like
lucky
with
roll of the
HIV.
dice in their genes.
There were people who had tons of contact with HIV, never got it. Also written up in the New York Times. And no one really knew why. We never got, at least I never got an answer as to what made them have no problem with it, but...
Well, I can tell you one thing. If you want to survive an infection with Ebola, this comes from unpublished oral data that Pardis Sebeti told me about. You need to be young. If you are infected with Ebola, here are the statistics for this outbreak, okay? If you are as old as 35 to 40, the case fatality rate goes up to 84%. You're already too old. If you are age about 43 to 45, the case fatality rate is around 93%. If you are in your 50s or 60s, you might as well kiss yourself goodbye. You know, the case fatality rate is probably going to be close to 90-something percent. Young people are surviving Ebola. Yes?
Richard, thanks so much for your talk. You started off by speaking about how you were going to talk about the human aspect, the human story behind Ebola, and I think you've done that so well. And I also wanted to see if you could just speak for a moment about the human-animal stories behind zoonotic diseases like Ebola. And I'm thinking in particular, of course, these zoonotic diseases, they aren't created equal. They're very different in their effects and how they're transmitted, but they do share this human-animal leap. And I'm thinking about culturally, this is a question about the culture of these diseases, and in particular Ebola, rather than the science. Thinking of diseases like SARS, avian flu, and the way that we talk about those diseases and the human-animal connection there. We tend to think a lot more about, you know, sort of what are the Chinese eating? Like, what are the wrong things that they're eating that they're getting that the diseases are coming into the human world from? And we don't hear as much about that with Ebola. You know, the fruit bats are a part of this, and that comes up in some of the reporting that we see, but we don't talk about it as much. And I'm just curious if you've thought at all about that difference. And that the human-animal story there.
Yeah, that's really interesting. I think actually that's correct. We don't talk very much about the human-animal connection with Ebola, except that there are these strictures. You know, don't eat bush meat. You know, that's ridiculous. The problem is that we don't know very much about the animal the connection to the animal world. We know that Ebola is coming out of an animal host. But in these outbreaks, in all of them, the early patients, patient 0 and the ones that follow patient 0 are dead. And so when the epidemiologist comes around to find out, you know, what were you doing? Did you eat a bat? Fruit bats are supposed to taste delicious. They're supposed to be not bad at all. Did you eat some bat? Did you kill a bat? Did you kill something else? Did you get a tick that was on the bat? Where was the bat? What kind of a bat? You know, or was it actually a rodent that you ate? Or you know, what was it? You know, the epidemiologists simply run into darkness because all of the early cases were dead and they can't talk anymore. They can't tell you what they were doing. Another thing that I think I do want to address this a little bit, which is the great confusion. There's been a huge amount of confusion in the public discourse about what airborne means and whether whether Ebola virus could mutate, you know, and get into the air and, you know, turn into some kind of Andromeda strain that's going to wipe us all out. So Eric Lander, the head of the Broad Institute, put it very succinctly to me. So Ebola virus is mutating. The longer this outbreak goes on, the more chances this virus has to develop a mutation that would really be dangerous for all of us. But it doesn't necessarily have to go into the air in order to travel more effectively from one human being to the next. The way Eric Lander put it was, can zebras learn how to fly? He said, that's really not the right question to ask. The right question to ask is, can zebras learn how to run 3 times faster? And Ebola could certainly do that. There are unpublished results showing that in some Ebola patients of this type of Ebola that we're seeing, they're getting up to 10 times the number of virus particles in their bloodstream than have been seen typically in previous outbreaks. So the virus is growing to tremendous profusion in human bodies. This doesn't necessarily make you sicker, but it might make you more infectious because you're just producing that many more particles coming out of your body. So that could be a favorable adaptation or a favorable mutation for Ebola. We just don't know at this point. And then in terms of airborne, there are really 2 kinds of airborne with viruses. There's what's called droplet infection, which is where, here we are. I've got a picture of you here. This is somebody sneezing, and you can see the droplets coming out of this guy's mouth, okay? These are liquid droplets, and they're of a size that causes most of them to fall to the ground in a distance of about a meter, maybe 2 meters at most. So the rule of thumb is when you're around Ebola patients, they could be throwing liquid droplets into the air. 40% of the patients in this outbreak are coughing. Coughing is apparently a major feature of the Ebola virus disease that we're seeing in West Africa today. People could easily be coughing particles of Ebola, small droplets of blood, but they're not going to go that far through the air. The other way that a virus can move is the way the measles virus moves. Here's measles. This is what it looks like. Measles is part of the Morbillivirus virus family, and in this case, the virus can travel through the air in dried form. The virus can survive drying, and it can essentially end up in small, dried dust particles that can travel 150 yards from one person to the next person and then get embedded deep into the lungs, where the virus can then activate, attach itself to lung tissue, and begin replicating in a new host. So with true aerosol transmission like this is a measles, and viruses from the measles family are actually far more dangerous than Ebola, because it's almost impossible in an outbreak to really trace the cases and contacts, because you can have somebody 100 yards away who gives it to somebody else, that's something that really alarms a lot of people. And the question about the animal kingdom, there are these morbilliviruses live in animals, and they have the potential of moving into humans, and they have done so in the recent past. Yes?
I was wondering, as a professional writer struggling to translate the story of from the scientific experts to the general public, what do you think has been the role of American media in conveying the story of Ebola? Has it been effective or beneficial, and could you describe this relationship?
Well, actually, I think the media coverage in the United States has been terrific. The New York Times and the Washington Post in particular have done a really good job covering the Ebola outbreak. They've had reporters on the ground really detailing the human suffering, getting into the questions of science. I think the print media has done a wonderful job. I never know about the video media. It's always hard. The video media tends to depend very heavily on the print media for stories in the United States, and they don't seem to have a whole lot of time to really get into things. But in some instances, I've seen very good reporting. CNN has done an excellent job in terms of video media. So I think in general, the media coverage of this outbreak has been quite good. Very good. Yeah. Yeah.
Thank you
Yes.
Again for your talk. I was wondering if you could talk a little bit about some of your research methods when you were gathering the information about this, and for the New Yorker article. Did you go to these hospitals in West Africa, or how did you get all this information?
Well, this is a really great question. I mean, I'm a writer, and I love talking about writing. And it's a somewhat different subject. I mean, I'm supposed to be an area expert in Ebola, right? But actually what I am is I'm an expert in writing. I love to talk about, I've been teaching some classes here at Yale. It's been a lot of fun. In this particular instance, the way I do, this is nonfiction writing. This is what we would call narrative nonfiction. And I typically spend huge amounts of time with my subjects. I get to know them as individuals. Very often, people that I've written about over the years become lifelong friends. It's just one of those things that happens. But when you spend a lot of time with somebody, taking a lot of notes, you end up learning a whole lot more about that human being that ever ends up in print. All the skeletons in the closet come out. You find out all about whatever medical problems they have. Typically, I never write about a person's medical issues unless it's part of the story itself. And I also get the cadence of their voice in my head until I can hear them in my sleep. I wake up in the middle of the night hearing my subjects talk to me. And in a number of my books, for some reason, I go back to the same characters in nonfiction. So I think I may be one of the only nonfiction writers I know of who has a repertory cast. So Peter Jarling, for example, the guy who whiffed Ebola virus in the hot zone, and he later said that whiffing Ebola virus from a flask was the second dumbest thing he ever did. The dumbest thing was to tell Richard Preston about it. But Peter is indeed, a good friend of mine today, and he's come back again and again. He's been in Demon in the Freezer. He was a major character. He was a source for 2 of my books without, being in the foreground. And I'm now at work on another book, and I think Peter will be back in that one as well. So I know this is a long way of answering your question. So it's a matter of taking notes and getting to know my subjects. In this case, I did not go to West Africa. I did all of my reporting at MIT and also at an NIH laboratory in Maryland, and I never went to Africa. I will be going to Africa for the course of the research on this book. And I never met Humar Khan, and I never saw the Kenema Hospital. But what I did do was I got to know members of his family. He has siblings, brothers and sisters, who live in the United States, and it's an extraordinary family. And I got a real kind of feel for this guy just by talking to the people who loved him. So that's how I did this particular piece of research. I don't know if that's an answer or not. And I love to talk about writing.
Okay, thank you.
Yeah.
I was wondering if you could comment on the ability of the world to be prepared for this outbreak, and whether you think that its failure was primarily maybe a scientific one, to underestimating the virus, or maybe an anthropological one to underestimating the conditions in which it could have spread.
Well, I think there's been a lot of finger pointing over this outbreak, and a lot of discussion of the failure of the World Health Organization to really get on top of it, and the failure of all kinds of medical organizations and governments to really understand what was happening here. I see it a little bit differently. I didn't, it would be only I would love to be able to get smug with you and say, oh, well, I wrote The Hot Zone and I saw this coming a long time ago. I'm sorry to tell you that I'm not really able to do that in any honest way. I think this outbreak really surprised people. It's always easy in retrospect. And, now we know. I mean, God, do we park our brains at the door, I mean, of course. You just think about, these crowded urban environments, and you put Ebola into a crowded slum in West Africa, or for that matter, if Ebola gets into Dhaka in Bangladesh, or anywhere in South Asia where hospitals are well known for not having adequate infection control, Ebola could could very easily leave West Africa. But I see this as not so much a failure on the part of the public health community, but as a natural disaster that just simply overwhelmed us. I see it in the same terms as, let's say, a tsunami or an earthquake, like the Japanese tsunami. Take that for example, okay? The Japanese had been preparing for a long time for tsunamis, but they just didn't think of everything. And they didn't think just how bad it was really going to be. And a lot of people died in the Japanese tsunami. And yeah, they could have done things better. But in the end, what we're seeing, I think, is essentially the impotence and the powerlessness of the human species to really control its destiny in the ecosystems of the planet. That in the end, if it wasn't Ebola, it's going to be something else. And personally, I think that Ebola is by no means the most dangerous virus on the planet. And in a way, what's happening with Ebola right now is an excellent wake-up call for very worse things that could happen. And I see this outbreak, regardless of where it goes. It could still go global, or we have epidemiologists right here in this room. We have one guy who's just come back from Liberia. I'd love to hear your thoughts on this. But he thinks that the epidemic curve may already be turning over. In other words, the number of cases may be flattening out. We just don't know what the future holds for Ebola. It's very unpredictable. But I think what we can think about Ebola is that it's a kind of case study. Mother Nature has given us a really interesting case study in what can happen with an emerging infectious disease when it comes out of some some little host in nature that we didn't think about. I don't know if that's really an answer to your question, but the way I feel.
So let me ask the corollary of that question. If, knowing what we know, and then you say, well, Ebola is now not just in one urban area, but it's in several, why do you think, and it's been there for months, why do you think we're seeing as low a case number as what we are?
I'm sorry, could you refresh us with your name?
Oh, Ryan Boyko?
Ryan
Boyko?
Ryan Boygum.
Yeah.
Great, thank you. So Ryan, you just got back from Liberia, right?
Yes.
Yeah. Thank you for your work.
Thanks.
Well, I heard one epidemiologist told me that he sees in this Ebola outbreak, he sees what he calls the fireworks displays. And he said, we don't really understand what Ebola is doing, but it goes off like a burst of fireworks in some place, like Conakry, the capital of Guinea. And then everything goes dark. And then the wards, all of a sudden, there's nobody in the Ebola wards. Where, weeks earlier there were 100 people and now there are 5. And then he said, but it's like a fireworks display. And then things are dark and then there's a bigger flash than before. And he doesn't understand, this guy doesn't understand what's actually happening with the Ebola outbreak, why this is happening. Do you have any insight into this? And he told me that, after things looked like they were totally under control in Conakry, now all of a sudden there's been a bigger flash of Ebola in Conakry, and there are more cases than ever before in that city. Do you have any sense of what's happening?
I have a few guesses.
Okay, let's hear.
So for one, behavior change is a huge factor. And every single building in Monrovia, even outside of the nicer areas, even in the slums and things, they have hand washing stations where with water with a bit of detergent or bleach in it. They have and other measures like that. But and nobody is really there's no handshaking. There's none of that going on. And not that those behaviors necessarily, in particular, are responsible for preventing too many infections, but I think that it's a testament to the fact that it's just always on everybody's mind. And at this point, I don't think that there's a lot of people who, who don't believe that it's real or don't believe that it's transmitted by bodily fluids or those kinds of things. And I think that regardless of what your customs are, if you see people dying in front of you or your neighbors have seen people dying in front of them, that has a big impact on you, and it changes your behavior. So I think that there's a lot of behavior change that just happens when people are terrified. You can, even in America, where 4 cases, you see terror and some crazy people being held out of school because they came from Rwanda or whatever. So I think that's one reason. I think another reason is that you see it's a series of very small local outbreaks is what it really is. And in any household or a block, there are people who are most likely to be the caregivers, and those are people who are most likely to be infected. And then after those people are infected and dying, I think you naturally, in that area, you're running out of people who have large numbers of contacts with very sick individuals. And so I think that's another part of that.
I got a question for you. What do they do with the bodies?
The question is, what do they do with the bodies?
The best way to...
So what they do, and actually this is another reason why I think the epidemic particularly in Monrovia at least, is decreasing, is that they got a lot better about responding to bodies. But even when I was there, there were lots of you'd see people gathered around and a team coming to remove the body. But basically, you have people dressed in full PPE that come, And there's a phone number you can call to report a body. And people will come in an ambulance and spray chlorine all over the body, spray chlorine all around it, put you in one body bag, spray that with chlorine, put you in a second body bag, put you in the ambulance, drive you outside of town, and they've set up an incinerator outside of town, a crematorium. So everybody who dies in Monrovia nowadays, with the exception possibly of like children of members of parliament or something, like you have to, but essentially everybody who dies in Monrovia now has that happen, and they go and they're cremated at night. They throw all of the bodies in there together. And I mean, this itself caused there was a lot of tension about this, that, you know, the family members they don't get any ashes back, there's nothing that they get back. So that in itself is a disincentive to telling somebody that your family member has died, but you know, anybody can call about a body or whatever. But you know, this is one of those tensions of infection control versus anthropological concerns, if you want to call it that.
Great. Thank you very much.
Great. Please join me in thanking Richard for his contribution.
Thank you.